Welcome back to the Daily Dean. So as I previously discussed Newton, I would highly recommend checking it out. I'm going on to the next part. What is a joule? Now the formal definition of a joule is applying a force of 1 Newton through a distance of 1 meter. That doesn't make intuitive sense, so let me break it down for you. We know that this battery, as I previously mentioned, exerts a force of 1 Newton downwards. So if I move this battery up and down 1 meter, I will have performed a joule of work. I watched this video from Electrician explaining the difference between watts, volts, and joules and whatnot, and his explanation for what work is basically doing anything to an object. If I lift up this screwdriver, push it away, lift up this battery, I am doing work to the battery. Even if it's, just, a little pushy or a little pulley, whatever, it's still work. And basically, a joule is just a way of defining how much work it is using numbers. Just like how defining a Newton is just defining how much push or pull something has, or saying that a water bottle, again, has 500 milliliters of water in it, and etc. Now, basically, a joule means that if you do more work, you're doing more joules of work, and etc., etc. And there's an interesting little relationship that this movement has with heat that James Prescott Joules proved using this little experiment. So, he found out that if he made this little device that had a pulley system. Basically, on one side you have this a thingy that exerts a force of 1 Newton, and it goes up and down, right? The thing is attached to a little paddle that stirs water. The stirring water will increase its heat. Now, if you haven't seen what a calorie is, I would recommend checking that one. It's the one titled Eating Glass and What is a Calorie. That one's cool as well, and you should check it out to get more context if you don't know what a calorie is. And as the thing goes up and down, it's performing work, right? And as the thing paddles, it's increasing the temperature of the water. Now, there's a thermometer that detects how high and low the temperature is. So after enough work is performed on one end, the temperature of the water actually increases in correspondence to a certain number of pulleys and pulls. Because again, look at this. This is performing work up and down. I'm moving this battery that exerts a force of 1 Newton up and down, which is performing work. So as more work is done, it's being transferred to the paddle of the water that's increasing the temperature. And he found it took 4,000 joules of work, which would basically be moving this 4,000 times, like an entire meter up and down. A meter is like 3 feet, a yard. And there's equivalence between 4,000 joules of work and 1 calorie of heat, or heating up an entire liter of water by 1 degree Celsius. Now, this is my favorite part, you may see the sun's output measured in joules per second. That's called wattage. It's really easier to understand. Joules per second is just, a watt. Watt is just joules per second, the amount of energy you output per time. So it's a rate. And you may be thinking, we just discussed how joules are, a physical work. How is that possible for the sun to do work like that if it's literally just light and energy? Great question. It's because there's an equivalent between mechanical energy, joules, and calories, heat. And there's even more related to mass, like E equals mc squared, but it's a little more complicated. But basically, because we know that 4,000 joules, it's like 4,200, is equal to 1 calorie of heat, we can convert, we can say that, if the sun heats up a liter of water by 1 degree Celsius, we know it puts out 4,000 joules of energy. So, if we know how much heat the sun is giving off to us, and we know the distance and the square law and whatever, we can find out. We can convert the joules to calories, which is something that makes more sense for the sun, because increasing the temperature of something, that's what a calorie is. It's all tied together. And this is the biggest takeaway I can give to you that is also in the Electrician video that I'm going to be putting down in the description below. Energy just changes shapes and forms. Mechanical energy to heat energy, calories, and, movements and kinetic and whatnot into gravitational potential energy, angular momentum being converted into kinetic energy, angular momentum being converted into thermal energy, whatever. It's all related. Energy can just shift forms and change however it wants to, or not, and change as according to the laws of the universe. And joules is just one way of describing it that is basically the international standard. So, I hope that you learned something, and I hope that if you were struggling on what a joule meant, this clarified some things for you. I hope that you learned something, and I hope you have a wonderful week. Bye-bye.